Okay, some more exponential growth or decay, graphing these functions. And this is getting a little more complicated. Y equals 1/2, 1/3 of the x minus 1 minus 2. So first of all, I want to find my new 0. So that's going to be with a shift. So it's going to be, looks like it's going to be 1 to the right. So positive 1 and down 2. So I'll find that new 0. Positive 1, negative 2. So there's my new 0. I'll put my horizontal asymptote in. Y equals negative 2. And I'll find some points now. My shape equation will be 1/2. It's going to be the equation without the shift, so it's just going to be 1/2 times 1/3 to the x. Watch your arithmetic on this one. So this is my shape equation. So this is all I have to find points for. So when x is 0, 1/3 of the 0 is 0, and 1/2 of 0 is 1/2. I'm sorry. 1/3 of the 0 is 1. 1/2 of 1 is 1/2. Okay, there you go. 1/3 of the 0 is 1. 1/2 times 1 is 1/2. Okay, when x is 1, 1/3 of the 1 is 1/3. But 1/2 of 1/3, or 1/2 times 1/3 is 1/6. Okay? And 1/3 of the negative 1 is 3/1. And 1/2 of 3/1 is 3/2. Okay? That might be a little complicated arithmetically for you, so all I can do it over here, I guess. Let's say to the negative 1. All right? You can see down here. So that's going to equal 1/2, and then if I take this to the negative 1, I just flip it, so it's going to be 3/1. And 1 times 3 is 3, and 2 times 1 is 2. So we have 3/2, which is 1 and 1/2. So that's kind of how you would work these out. Okay? So I can put my points in relative to my new 0. So 0, I go up 1/2. And when x is 1, I go up 1/6. And when x is negative 1, I go up 3/2, which is up 1 and 1/2. All right? I'm getting closer and closer to my horizontal asymptote this way. I don't know what's going to happen this way, so I could try negative 2 and see what happens. So let's put a negative 2 and see what happens. I'm going to do this down here again, so I'm going to say to the negative 2. So that's going to be y equals 1/2, and that's going to be, there's a couple ways to do this, so I could say this is going to be 1 to the negative 2 all over 3 to the negative 2. This is kind of working it out, a lot of extra steps, but you can just flip it, and square it. So it's going to be 1/2, and that's going to be 3 squared over 1 squared, so that's just going to be 9. So that's going to be 1/2 times 9/1, so that's just going to be 9/2, which is just going to be 4 1/2. So that's what you got there. Okay? So when it's negative 2, it's 9/2 or 4 1/2. So we'll put that point in, negative 2, go 1, 2, and up 4 1/2. 1, 2, 3, 4 1/2. And that'll give you a little bit better idea for the contour. And we'll go like this. Let's make sure you're getting closer to that asymptote. Not farther, okay? So you can see as we move to the right, the vertical position is moving down, or the value of the function is going down. So as I move to the right, I'm going down, so that's exponential decay of the domain, negative infinity to infinity, and the range is going to be from negative 2 to infinity. And again, we've got exponential decay. All right, and another one. Y equals 3/4, 2/5 to the x plus 2 minus 1. So let's find the new zero first. So that's going to be the shift. So it's going to be 2 to the left, down 1. Negative 2, negative 1. So that's my new zero. So I'll put that in right away. Negative 2, negative 1. There's my horizontal asymptote. Y equals negative 2. Okay. And I'll find some points here. Well, these are going to be a little bit more complicated arithmetically. Again, my shape equation is going to be everything without the shift, so it's going to be 3/4, 2/5 to the x. So when x is 0, 2/5 to the 0 is 1, so I'm going to have 3/4, so that'll be the easy part. Now when x is 1, I'm going to have 2/5 to the first power, and 3/4 times 2/5 isn't too bad. Numerator times numerator, denominator times denominator. So 3 times 2 is 6, and 4 times 5 is 20. So it's just going to be 6 over 20, which is about 3 over 10, or a third. And negative 1, now remember when this is negative 1, basically we were just going to flip these, so it's going to be 5/2. So I'm going to have 3/4 times 5/2. I better write that down here and look at that. So I've got 3/4 times 5 over 2, and that's going to be 3 times 5 is 15, 4 times 2 is 8, and 16 over 8 is 2, so we could say that's approximately 2. So we'll say 15 over 8. So we're going to put those points in relative to my new zero, which is down here, negative 2, negative 1. So the first one will be from that, I'm going to go up 3/4. Then I'm going to go over 1, up 1/3, or 6/20. I'm going to go to the left 1, up about 2. To the left 1, up about 1, 2. But just a little bit below 2. So there's my curve. And I'm not going to fool around with any other points. I'm just going to kind of use that contour. I'm not going to... Well, if I go over 3, what's that going to be? I might get that on the graph. So over 2. So let's try negative 2 and see. Can't leave it alone, can I? So I'll try negative 2. And that's going to be, flipping that, that's going to be 3/4 times, and if I flip this and square it, it's going to be 5 squared over 2 squared. So it's going to be 25/4. That's going to be 75 over 8. And 8 goes into 9 times. That's just going to be, I'm going to barely make it. That's going to be a little bit bigger than 9, so it's not going to really help. So I'll just have to stick with those. So I have an idea that it's going to maybe be around here, but it's still going to be a little bit bigger than 9, so it's still not going to be on my graph. So I should have left it alone like that and use that for my contour. Like I said, if you just use these 3 points, you're okay. It looks like we've got exponential decay. Again, in this case, our A was 1/2. In this case, our A was 3/4. All right? So it looks like I've got exponential decay. Looks like my domain is going to be negative infinity to infinity. Looks like my range will be, oops, y equals -1. Why did I write -2 here? Excuse me. this is your horizontal asymptote y equals -1. Pardon me. Okay, this was -2. And my range is going to go from -1 to infinity. All right. Okay, so my horizontal asymptote is y equals -1. I've got exponential decay. I got my domain and my range, and I've got a pretty good contour on my function. Okay? So I hope that helps.